Good afternoon, everyone. Welcome to the, is it 3:30 session today at Build? Find my clicker here. My name is Chaz Boyd. I work on the DirectX team inside the Windows graphics team. And we work on the game scenario as well as part of our charter. So today I'm going to talk about some of the middleware technologies that are available for game developers to use in creating cool games for our new API platform that, for example, you can run on the Surface RT and similar lightweight devices. The objective here is to kind of give you guys an overview of the technologies that are available. It's not going to be a long talk today, but I'm hoping that we'll be able to have some discussion about some of these technologies as we go through them. So we'll do a little bit of an intro on sort of how we got here, and then we'll talk about two categories of software technologies that are out there today that games typically rely on. First being the open source technologies that somehow find their way into games code bases, and then also the a little bit on some of the more popular or more highly visible commercial third-party components that are available for developers to use in creating modern applications. And I've got one slide on tools. Okay, so the key message that we're driving at this conference is that the PC itself is growing into a new set of form factors that it wasn't really capable of earlier, right? The hardware wasn't there, the software wasn't there, the user interface technologies weren't there. But now, as of Windows 8, we've got a solution that allows these devices allows PCs to operate in the sizes of devices that used to be only for phones, really. And as developers begin to understand this, they're able to create a new range of applications as well that starts, not just typical PC game titles, but also a new generations of content that are targeting the broader range of situations that users are in when they're playing a game. It used to be on a PC gamer could be found in the basement with the headphones on late at night, bent over a mouse and keyboard. And as the PC broadens its availability into these new situations, we're seeing new types of users come along that are really what's causing the interest in these new applications and the new middleware that they are based on. That previous slide was the Microsoft specific APIs, and these are specific technologies, and these are some of the ones that are provided by third-party studios. So our effort to help with this has been in Windows 8 and in 8.1. We constructed effectively a new API platform where, in the process of doing so, we took a look at all of the APIs that were available in Windows. So graphics APIs, audio, input, a variety of technologies, and we said, okay, which are the ones that are most likely to be useful? Which are the ones that are already most popular or most effective at creating an excellent game experience? And we made sure that those were part of the new platform. And that includes not just the basic sorts of things that you would expect with like touch and accelerometer, but also we wanted to make sure that the core technologies available for high-end games like Direct3D and mouse look from a first-person shooter were also included as part of that platform, because the goal was not to create a separate platform for tablets, but to make sure that the new platform can span everything that PCs do today and be able to run those scenarios on tablets as well. But one of the things that we found as we specifically focused those technologies or identified the ones that were most appropriate to the game developers, there were several that were of particular interest. And in Windows 8.1, we added even more. Specifically, we've added new features to Direct3D, which we've already talked about at the show. We've added such things like tiled resources and hardware overlays, which are important for tablets. But we also improved the story for store installation and how to, some issues, some improvements on how to connect game players together using Wi-Fi Direct, and then a little bit on our tool story as well. And so as a result, we ended up with a platform that we think is a pretty reasonable solution for creating games because of just the spectrum of technologies that are there. This is kind of just a breakdown between what was added in Windows 8 and what was added in 8.1. And so we're thinking, okay, that's fantastic. We now have an opportunity for a huge number of developers to create exciting experiences using all the best technologies that have always been available on Microsoft platforms. And then the question is that really enough? Is that all we needed to do? And the answer is, you can always do more. For example, we find that a lot of games out there today that are on high-end devices and well as low-power devices contain technologies that were sourced from other locations besides Microsoft. And so because we want to have a lot of games on our platform, we want to make sure that there is a path for those types of games to appear on the new platform. And so the reason that developers use these technologies is not complicated. It's because they have there's functionality that's easier for them to incorporate from a third-party solution than it is to rewrite for themselves, and that gives them a quicker time to market. It means that the game hits the store in a time when the buzz around it is still hot, for example, or the buzz around that type of genre is hot. It also means that they have a more potentially predictable scale of time in which to estimate how long their development costs will take, because they know that most of this code is pre-written. And theoretically, also, some of these third-party components have been also tested and therefore are a fairly stable foundation. If you know that another developer has made a fair amount of money or successful products based on a particular code technology, then you know it's a much lower risk for you to incorporate that technology as well. And the other thing that is interesting for a lot of these third-party components is that they, in many cases, help you with transitioning your code base across platforms. So if you're coming from another platform onto Windows, or if you're looking for a solution that helps you create a consistent experience across the Windows Phone, or the Windows RT tablets, or a PC, or a high-end SLI gaming rig, those middleware components that you have seen another developer use on those different configurations, then that's a pretty safe bet for you to incorporate. So it helps the Microsoft developer span, our solutions, which are console, PC, and phone, and that's a good thing for everybody. So these factors apply to both the open source and the commercial technologies. You still want to check to make sure that robustness is provided in your solution. So what we've done in several of these instances is open up communications with the teams that are creating these products and offer our assistance to help them make sure that they've optimized their technology, or that those technologies are optimized for the platforms that Microsoft ships. So let's see here. So let's take a look at some of the open source technologies that are in this category. First of all, one of the nice things about open source is there's usually a couple different options. A lot of these sites will have already pre-built a set of binaries and headers and libs that you can just incorporate into your project. And as long as you get the right ones for the binaries, right binaries for the platform that you're shipping on, and you set that up in your configuration system, it's the quick and easiest way to get up and running. But one of the other options is with open source, you have the ability to incorporate that into your build project. And this has two significant advantages. One, you have the option to go into that code and understand it. It's often very well documented, but there's still nothing like being able to go in and look at that code and see exactly what it's doing to help you understand how to integrate it into your application. But the other thing is that if you find some change or some tweak that you need to make to get it to integrate well, you have the option to go and change that piece of code from the open source community, depending on how the licensing for that technology works, and get unblocked from whatever issue that was causing. Now, the open source community would like, depending on the license, for you to then check that change back in if it's a general fix that other developers would benefit from. So that's kind of being the good citizen of the open source community. So what we did, and I won't say we did this for every one of these technologies, but what we tried to do was help out where we could. A lot of these technologies already had very effective, complete solutions already working on Windows Metro and the new environments that we support. But we tried to make sure that, for example, there was always a nice .sln file provided for these so that you know that the build environments that we ship, like Visual Studio, will just be able to launch that project and be able to build it. And that's really a good indication that it's actually up and running and complete. And then we also wanted to make sure that we validated that by running some test apps that use that library against the Windows Store Certification Toolkit, the Application Cert Kit, ACK, to make sure that there weren't strange methods being called that would cause security problems down the road. And then many of these projects, they had sample applications that you learn from in terms of how to incorporate that technology in your application. You're going to learn of that by looking at how those libraries are used in the sample applications as part of that project. So for that to work, or for us to know that those samples are actually going to be useful in helping you with that, we wanted to make sure that those had been ported over to work as full-on Windows Store apps. And I'm going to be showing you a few of those today, pretty much one from each component, just to prove that they actually are functional today. And in some cases, there were other improvements that we could make to some of the samples, just enough to make them look prettier. We didn't have a lot of other options as far as UI toolkits, so we made sure that the user interface technology that they had in those sample applications was the XAML that would actually work in the Windows Store. And that's really how we, those are the sort of things we cleaned up in some of the samples. It's not something that really affected the core code base, but it's enough to make it so that when you present these technologies to someone, they actually look their best. And then, of course, we also wanted to make sure that they actually ran on the ARM processors. And that meant, in some cases, identifying ARM-based assembly and other assembly language components and converting those to Neon. And that was probably one of the more challenging areas that you run into, is that the different development environments out there for some of these open source technologies have very consistent syntaxes for C++, but they all use slightly different syntaxes for the assembler. And so if you've got assembly language dependent code in there, it's often something that you have to pay a little bit of extra attention to when you're transitioning to a new platform. And the motivation for all this is that there's a lot of source code that we know people need to be able to build good applications with. And so we want to do everything in our power to make sure that that source code is available to those people and of very high quality and works well on our platform. And the advantage on your side is that this lets you guys spend your efforts, instead of fixing issues with a third-party library, actually focusing on the unique aspects of your game that make it a special experience on every platform, any platform. So this is a summary of some of the open source technologies that we looked at. They should usually be familiar to you. The Box 2D stuff, there's Ogre. Bullet is another physics library. Angle. SharpDX is the red X with the hash sign behind it. I don't have text underneath it. Underneath that is MonoGame, obviously. Then on the lower right is Cocos. And then ImageMagick is some image processing libraries that we took a look at. Okay, so with Box 2D, this is a physics engine. And it's really optimized for the 2D scenario like you would see in a sort of common tablet game today. There's some really nice games out there that use this. Crayon Physics is one of my favorites. Also, a lot of the initial versions of Angry Birds and similar highly popular, highly visible titles started with this code base and went on to huge success. So it's very robust, very stable, very widely adopted. A lot of people have checked in a lot of improvements to this over the time. It was even used in early versions of Cut the Rope, for example, where they had their new rope. They had to add ropes basically to the feature set because you couldn't have Cut the Ropes without ropes. And so we've seen a lot of, excuse me for a second, success people using this product. And so what we did in this case is we worked with we engaged with the community. We find out who the people are who are working on it. We have a special team inside Microsoft whose role is to open source team effectively to work with these teams, these products. And we engaged with them. We said, okay, what can we help you with? What sort of optimizations can we, do without getting in your way? And then they showed us what they needed done and how we could do it. And so we're in the process of, right now, making the final paperwork to be able to distribute these components to the community. And so as a result, we have this pretty much up and running. I'm going to give you a demo now of the Box2D product. So this is my dev PC right here, my laptop. It's got a subwoofer. And so you can see these are our standard Windows 8 tiles. This is the Box2D icon. And this is their sample app. It has a variety of different test scenes that you can select from this menu. But this is really the basic one here, which is a vehicle simulation. They actually have the full suspension modeled in 2D here with the positions of the wheels relative to the mass of the vehicle being controlled by dynamic springs. And they have actual drive in terms of a motor that is causing the rear wheel of the vehicle to spin with some particular rate. And you can still see it still spinning there. So that's kind of the objective of that product. You can drive it around back and forth. There's a couple of other interesting scenes I wanted to show. This one is just because it's so mind-bending. But this is Theo Jensen's Walker, which he's an artist in Holland, I believe, and he makes these sculptures that he sets out on the beach, and the wind blows them, and they rotate, and they animate, and they walk across the sand. So can all be modeled from 2 dimensions at least in a program like this, and you actually get physically correct simulation based on the different levels of friction, and then I guess those are rocks on the beach or seagulls or something. So we'll go back to the PowerPoint now. One of the things I wanted to point out there is that this is an instance where we actually, just to show off the sample code here, just to show off this particular sample, this is the version, kind of the before picture when it was running on classic Windows, and it didn't have anti-alias text or lines. So you can see that the lines are kind of jagged there. And when we went, and then the text is the gray Win32. So when we went to the new version, we've updated the UI to be XAML, and then we're using a higher quality anti-alias line rendering, just to make it so that when you're looking at these samples, it's more clear what's going on, especially when you're dealing with these little wheels and gears and so on. It's better to actually be able to see what's going on. Okay, so another commonly used physics library is this library called Bullet Physics. And that's one where it's not everything constrained to a plane. There's actual full 3-dimensional behavior of objects in there. There's cubes and spheres, and it supports the same types of joints and springs and so on, but also objects can tumble and fall in arbitrary directions. And this is also very popular, very widely used. I think we just saw the Halo guys in here last talk mentioned the fact that they use this in their Halo game, Halo Spartan Assault. So it's, again, something that the community has had out there for a while that we've been working on as a whole. In fact, we actually contributed some direct compute-based fabric animation to this library when we first shipped direct compute in Windows 7. And so recently we went through that code base and made sure that everything in it would work well with the new platform. And by and large, that wasn't a lot of work on our side. It's one of these things where you get these code bases that have been used by so many people in so many different places. They're incredibly robust and they're incredibly widely applicable in terms of the number of platforms that they can actually run on. So the typical physics demo for an application like this is the falling cubes, and I think I'll try that too. So let's see, they've even got an icon for it. You can just spam those spheres everywhere and they just go around like a maniac. And there's a screenshot of the Hydro Thunder app that's in the store that's already using this. There are several others. Okay, the next code base that we're looking at is, this is a library that's specifically focused on rendering. And in this case, its purpose is to emulate a phone-style graphics renderer like OpenGL ES on top of the Direct3D. And for example, it enables you to port application code from iOS or Android onto the new Windows platform. And it's already been used by a lot of different products, not so much on the store yet, but certainly on the desktop. There are some extremely popular and widely used products that rely on this technology. So it's fairly robust again. The challenge with this is that up till now, it's been based on the DirectX 9 level of functionality, which we're trying to deprecate, really. And we're encouraging people to go to DX11, and by and large they have. A lot of people have done this, but Angle was kind of one of the ones where we had a version a few months ago. People started on it, well, a year ago, and then they tapered off, so we came in and finished that version that the community had already built, and now we're in the process of doing final testing on it and working with them to get it integrated into their main code base right now. In general, what the message on all these technologies is, the situation in terms of exactly what's checked in right now is changing from like day to day or week to week, but I can safely say that if you have a code base that is relying on any of these technologies, you can start building it against our platforms now, and by the time we get it, by the time you're able to actually ship your title in the store, we will have the full solution checked into the commercial, and to the standard source tree, the open source tree. One of the challenges that was also something that we had to do, and again this was our issue, was that OpenGL, in particular OpenGL ES, often, it's not required, but usually requires shaders, the actual rendering code, to be compiled at runtime. The APIs encourage you to ship ASCII source code of your shaders, and then whenever you're going to use them, you load them through the GL compiler that's part of the API. And contrast that with DirectX, where we encourage people to treat, most of the time encourage people to treat their shader source code just like they would their C++ code, and then kind of precompile it offline. That way we can spend a lot more time optimizing that code in our compiler and make it so that the experience for the user is not, is very optimal, because they don't have to wait for compilation to happen. Right now, people sit there watching a progress bar a lot of time, waiting for their level to load, and what's going on there is shaders are being compiled. So, but since that's the way GL worked, one of the things that we did in Windows 8.1 is we now enable the Metro apps to use the shader compilation. Specifically, we've gone and added the HLSL compiler that's used to generate all of these binaries for your GPU to the system folder. They're now part of the operating system. And so you don't have to ship that compiler as part of your game. It's not in the display driver. It's not anywhere. It's just built into the system for all the users of Windows 8.1 and later. So again, I've got the link here if you want to go to that site and get access to their bits and download it. Again, several people have done this already. It's the place to look. And what I want to do is demo this as well. So again, I'm going back to my wrong button. That's usually fatal in a video game. Wrong button. Back to my start menu and select this application. It's your basic standards asteroids app. The nice thing about this is that it's using a fairly simplistic, line drawing routine, which GL applications, have historically started in the CAD space. Yeah, I'm in God mode, so I'm immortal, but, it's a demo. I don't want to look too bad in public. But the nice thing about this is that all these glows and flares that you see around all these objects are due to fairly sophisticated image processing, post-processing passes, which are applied to the scene once it's done. And that's another technique that's very commonly done in games today. I should probably put my glasses on. Okay. The next code base is this product called Cocos 2D. And in particular, there's a version of Cocos 2D which is an open source library for creating sprite-based and sort of 2D animation-based applications. It's extremely sophisticated. The original version, sort of Cocos 2D without the X, is targeting specifically iOS. And so most of the code, or at least the APIs for it, are designed for Objective-C. But that makes it a challenge to run on Windows or Android. So that's why there's this alternative branch of the project called Cocos 2D-X, X meaning cross-platform. And it's an extremely sophisticated solution. I think that, there is pretty much nothing you could ever think of to do with a sprite that is not supported by this library. It's just amazing. In particular, it has already incorporated as part of the project the Box2D library, so that you can have physically based interactions between the sprites in your application that's built into the same system. And there's a higher level API that you can use that drives that physics layer in a way that's even more intuitive. Again, this is a community that's been very open to us helping them, and we've made some contributions there. We're in the process of checking those in right now. And as a result, we know that we've got this capability for now Windows 8, RT, and Windows Phone all across the board. Has anybody ever used this? Cocos? Yeah, it's just, you have to remember, okay, sprite games have been around for a very long time, and people have spent a lot of that time thinking about how best to do it, and a lot of that culminating work shows up in this project. So again, I've got a demo here. They have a nice tile set up there. What do I usually do? Particle test. Particle test. There's a comet. Bunches of cool types of explosions, asterisks. So this is all using very high performance GPU accelerated compositing of these sprites so that you get the nice alpha blending, in this case with the additive blend that adds up to white in the middle due to the saturation logic. And this is their basic stress test app that lists, a few thousand different things you can do with sprites. And I'm just playing you back some of the prettier ones with the test sample app that they ship. So again, this is a technology that if you were to start using it today, we pretty much would be able to guarantee that by the time you're able to ship, that it would be completely functional for you to actually use in a project. The work that we can do right now is check fixes into the core trees on these products that enables the core operation to work. But in many of these projects, there are more peripheral components like things like file importers and exporters and various types of tools that all represent more work that we can probably continue to look at to make sure that works well too. And then also, one of the ways that we can work on these is to go and find other open source applications that have already been written on top of these libraries, and then make sure that when we're able to turn those into modern applications, and when we do that the library itself doesn't pop up any issues at that point. And so there's always more we can do to try and guarantee robustness. But as far as we can tell right now from the samples, these are ready to go. Okay. Another really popular open source technology out there is one called Ogre. And this is not something where we've done anything at all, really. We're just sort of, trying to see if there's anything that they need any help with. And so far, it doesn't look like there is. For example, this technology has had a Direct3D based backend for a long time. I think it's even got some decent DX11 support coming along. It's very widely used in some popular games that have shipped already. And if you're looking for something that's a little more featureful than just writing it yourself in native code or in maybe even low-level managed code, this is the next step up, right? It's a tier that's in between something like Unity, where there's a full-on end-to-end engine, including authoring tools and everything, but it's much easier. There's much more technology here in terms of how to manage shaders and how to manage assets that if you won't have if you just start with raw DirectX code and C++ at the bottom. So that's a whole class of applications and title developers that are at that point where they want something that doesn't include a full game engine in terms of physics and everything else, like Unity has, but it's still easier to use than just writing it all yourself from scratch using direct C++ calls. And the nice thing about this is it does appear to run on Windows Phone. I don't have a demo of this. Let's see. But that's an example application, example of the type of content that you can write. This application was created by Runic Games, and it's called Torchlight. Excellent product. I play it a ton instead of working on my PowerPoints. Okay, now, for the C# developer, there are a variety of solutions out there as well. I know there's a lot of C# people that come to this conference. And so kind of following in that same theme that we were talking about just now, there's a spectrum of levels of abstraction that you can target with C#, I mean. And in this case, the lowest level of abstraction that's available out there now is an open source project called SharpDX. And this is a really awesome version of, it's really sort of the minimal amount that you need to do to take high performance DirectX calls and make them available directly in C#. So if you like programming to the metal, but you just don't want to use C++, this is your solution. And now they've actually gone beyond the graphics in this and added similar, relatively low-level interfaces for all the other things that DirectX, games would need, like joystick input. It's got wrapper code for X audio and for X input, and the file loading routines that we include in our C++ samples. Basically, there's a lot of the sort of lowest level technologies that we support exposed through this interface. And again, we didn't do any work on this really. we're just very pleased to see it out there. The next tier up, when you're looking for something that's a more complete solution, a full-on game engine, is, for example, something like MonoGame. And this is an open source project where there's a large amount of community involvement and investment happening right now. The only thing we've done is really minimal, is just say, okay, here's the specification. We kind of opened out the XNA 4.0 specification and offered that, contributed that to the community so that they can build now this MonoGame project that runs not only on our platforms, but on other platforms as well. And as you can see, there's a significant number of really cool games out there that are based on this technology. And developers came to us and they said, we like XNA, but we wished it ran on more platforms. Well, one way to do that is to just offer the standard up to to the open source community, and then they can build this solution that spans all those other platforms. And there's some people here in the audience I know who work on the project, and we're really glad to see that continuing to happen. In fact, there was a talk on this recently, I think a few months ago, about how to manage the transition from XNA to Windows 8, where the real XNA isn't available as part of Windows 8, but MonoGame is. So that's really your solution there. Okay, so at some point, maybe we'll do this at the end, I want to make sure that you guys all have a chance to at least come up here or whatever and let us know about other open source projects that are worked on at SourceForge or someplace like that right now that you expect to need, that you would like to have, or that you want to make sure runs well on the Windows platforms. So anytime you see any of us around with a Microsoft shirt, let us know. On the commercial side, there's a ton of commercial technologies out there right now, and I don't have time to discuss them all. I'm just going to provide a few highlights. These are some of the companies that have already announced their intent to provide support for the Windows RT and the newer platforms from Microsoft. And we're really glad to see this happening as well. And in most cases, unlike the open source case, we don't have to go and help them fix their code usually. We just have to explain to them some of the ways that our code works, and that's how we end up with better products. I just want to point out some of these technologies actually will provide you the source code as well, and then you get a lot of the advantages that you would from open source. But the other thing that they provide in many cases is a more end-to-end solution where you can start with a Photoshop image and they have an art pipeline that will feed that directly through their technology and out into a game. Okay, so Unity. I know you all heard the Unity announcement, the keynote this morning. This is kind of the next tier up if you're looking for an increasingly sophisticated solution in C#. Because the nice thing about this technology is that it lets you program most of your game logic or whatever other elements you want to combine using C# for a very high productivity, but it itself is implemented in C++, which means that you get high performance direct 3D rendering, you get shaders and HLSL. All those things can run at very high speed, and that gives you this combination of the best of both worlds, where you get an easy to use language for creating the code that you want to write, and then the implementation itself does a really good job. For example, what this does is you can create a Unity project, and when you generate it, it actually generates for you a Visual Studio project that contains C++ and HLSL and C# code that integrates into a very high quality solution when you actually ship it. So this is really one of the most popular game engines on the planet right now, especially considering the fact that it spans the low-end phones and then tablets and then laptops and so on, all the way up to consoles, as they mentioned this morning. So there we had an event with them again a few months ago where we included some presentations on how people were transitioning their code bases between different machines using Unity. And it's a very nice story that they've got. So we've done a lot of work with them to make sure that the entire architecture that they ship is very well optimized for all the different technologies that we have inside the operating system, and that they're using, for example, the managed interfaces efficiently, and that they're using the display interfaces efficiently, being able to compose things, be able to put nice user interfaces on, and making sure that performance is always good. And that's been, really easy for us because their programmers are really smart, and we just tell them a few things, and they go and they make the thing, much better every time. And so, if the fact that we've worked with them to make the product free on all of our platforms basically shows you that we intend to keep working with these guys, and that we would really like you guys to keep working with them too. And okay, another challenge that developers often have is today people expect their applications to be connected, to offer services to the user that you really couldn't get from only operating on the machine that they're holding at that point in time. And so, for example, if you want to have the ability for an application to share your stats across another application, or be able to check your stats from your from a web page when you log into your den PC later, these are all the kinds of things that people just expect. But there's a variety of different ways to implement those. You can roll your own using Azure, for example, which is very easy. But this is a commercial library that actually delivers the key scenarios that you need for those types of connected experiences. It provides an authentication service that lets you recognize a particular user. So that's important if you've given them in-game purchases, for example, or if you want to associate them with a leaderboard ranking. It also supports the ability to have you group your friends into a list and then track those IDs accordingly. It has simple APIs to let you post your own player stats or manage and create leaderboards, and then something analogous to achievements. It also supports some level of matchmaking. The thing we see in a lot of cases is when you're dealing with phones, people create applications that are what we call asynchronous multiplayer, where if I'm playing against a few hundred other people and we're all sending words at each other, and kind of the crowd is answering my question, and the individual person that I'm talking to at that point in time is not really important or kept track of. But these guys provide not only that type of scenario, but also the standard sort of PC gamer style, hey, I want to play against you, and we're going to play cards or deathmatch poker or whatever it is. And it's really nice to have an API set that offers both of those types of multiplayer scenarios, both in terms of the actual runtime connection and then the matchmaking connection process of building up that runtime connection. And of course, it runs on the Windows Phone. And so they've got a web page set up on their site right now. And so if you go to that web page, you'll be able to see their Windows 8 story playing out for you. And I thought I would also, sneak in a plug for some of our connected technologies, which, they may not be as complete, but they're there. Like I said, you can build with Azure from a very basic level that you would control your own. You can actually, if you get published by the Xbox Live people, they've got a connected game service as well. And one of the things I want to point out is that every application that you write for the Metro environment in the Windows Store, you should put a share contract in that at least shares your own app. And the way to do that is you link to the store page that your app comes from, and that way you can easily do things like forward that link to people on Facebook that you know, or those types of things. What we're seeing people now do was a game I was playing this morning. You play the trial version. When the trial expires, or at the end of every trial, there's a button, and when you click it, it puts you to the store page that lets you buy the full price version if you want. So there's a lot of ways to exploit the connectivity of the platform and the network as you go. Okay, there's another commercial product out there right now, which is produced by a company called Havoc, and it's a very popular physics library. It's used in a large number of games out there right now. It actually includes a full-on 3D rendering game engine and additional components. And they're working very closely with us on products that are highly optimized for Windows 8 and Windows Phone, and of course the console as well. So they're another great partner that we work with, and they're continuing to provide more and more technologies, not just for high-end AAA type experiences, but also for indie games and casual games as well. So there's a lot to be look for and coming from that corporation as well. And this is the link to their webpage about their Windows 8 offerings that they already provide. Okay, this last technology here on the commercial side is basically a commercial product for translating OpenGL ES onto Direct3D. And these guys have been shipping on Windows Phone. There's a couple games already in the store that I have downloaded at least that use this technology on the phone. And they're in the process of generating their solution for Windows 8 and Windows RT. The nice thing about it is, again, they go beyond just the graphics component and provide an input mechanisms and audio and file I/O and so on to give you a more complete solution. I don't think it does physics, but it has pretty much the fundamental components that you would need that are likely to be platform dependent. So if you write your technology using this, your application using this, you'll have an easier time to make it run on all the different platforms that are out there. Okay. And that's their URL. Okay, now this is a company that's got and also a very complete solution. It's targeting the Sprite scenario, and I put that picture there at the bottom because it was off of their website, but it completely aligns with the picture that we started this talk with, because they get it. They understand that there is no need to segment your product offerings between phones and tablets versus PCs and notebooks. The user should be able to choose what experience they want to have on whatever device they happen to be on at the time, and this is a really good technology to enable that. It's a 2D games engine that, again, is very sophisticated, has a very nice authoring environment, user interface, an IDE basically for creating 2D sprite-based games, and then also incorporated within that IDE, there's a nice third-party sprite asset store that you can go and buy pieces that you want to put in your application, and this is their URL. Okay, and then there's one more company that I thought I would mention here, which is Graphene, and these are the guys that did the middleware component that was demoed in the keynote yesterday about high-end 3D graphics. So they're really cool, and we just want people to understand that, we're about inclusion in all the way from sprite games to the absolute latest bleeding edge GPU technology that's just coming out right now on the silicon side. Okay, and then the other thing, we are working with our content tool creation partners to have better solutions for creating the types of applications that people want that span all these different types of devices. And they're also very good partners that are very responsive to our needs. Okay, and so the final upshot of all this is that we understand that it's not sufficient for us to just ship a nice set of APIs in our product, but we also need to make sure that all the other APIs that are out there that people rely on work well. And so that's why we've been making these investments. And as a result, we believe that all the common middleware that you would potentially need is out there right now, so that there's no reason that you should say, okay, I can't start on my new Windows Store game because such and such component isn't available. We think that we've kind of fixed that problem, or we will in the next week or two, depending on how long it takes these things to check in. And So that's not an excuse. And if there's some other component that we haven't got on this list that, say for example on the open source side, that you'd like to see us help someone with, then just let us know. But that's our story, is that by now all these pieces are ready enough that you can just go and start on your application. So our recommendation is, when you're looking at some of these components, make sure you got the latest version, or if you're going to use a source code, then you don't need to worry about that as much because you're always going to build it. One of the things to keep in mind is that if you download, for example, an 8.0 Windows 8 version of a middleware component and you submit it as an 8.1 application to the store, the onboarding certification will fail you. It's a particular quirk of how the versioning of things worked. So you need to either get the 8.1 version of the library or just build it as part of your project. And then at that point, it doesn't matter whether you submit 8.0 or 8.1. It's always going to be in sync. Just they're trying to avoid scenarios where you've got parts of your library compiled with 8.0 and parts of it compiled with 8.1, parts of your application. Anyway, if you set up an 8.1 environment and build them all, it just works. And then, our recommendation is, make sure that the code is running well, and then just ship it. And the nice thing about that is once you're now on the platform, you've got all this code running on our new platform, that's when you get to go and do get paid, basically, by getting the payoff of adding all the cool new stuff like live tiles and contracts and automatic dynamic notifications and so on, that really make customers understand that your product is a professional product because it's got all of the features that the platform supports. And the nice thing about shipping a professional product is you're more likely to get paid for it. Okay, so that's it for me today. And I'm just continuing to put this point up there, which is let us know if there's anything else we're missing. Thank you very much. And I would like to take questions. We've got at least 5 minutes and probably more than that. Hello. Yeah, I'll repeat that. Yeah, this is the Marmalade people in the audience, and they're announcing that there is a free Marmalade giveaway happening right now. Should we go to your booth in the, or just get her right there? Okay, so yes, Marmalade's excellent partner, and they're really on board, and we'd like to see more of that. Anybody else? Okay. The question is whether the asteroid sample is available. And the answer to that is not right now, because that was written by one of our guys as his own test case for Angle. And the stuff that's checked in already is the test cases that the Angle project team wrote. But depending on how I'm able to convince that person, he may be able to check that into the Angle project as well as a sample. Otherwise, he may just ship it on the store and make a ton of money, and then we're all kind of sorry. Okay, well, I'll be up here, and if you have any other requests, just come on up and let me hear it. Thank you.